Alina, that was amazing. And actually, really, Dave, when I sent this to you, I should have maybe changed the title a little bit. That was somewhat of the abstract. We're going to be talking about chaos engineering fundamentals. And a lot of this is going to actually tie into some of the things that Alina talked to us about. And one of the things that stuck out to me was praise proactive homework. And so I think you'll be able to see how we can leverage chaos engineering to be more proactive. But who remembers this outage? If you want to go ahead and raise your hand or pop it in the chat there. But right, 2017, AWS has that S3 outage. It affected a lot of people. And there's a link here to the retro, but the summary is just that an engineer intended to cycle some of the S3 billing machines, and with most things in tech, turning it on and off again usually solves the problem. So the engineer issued a CLI command, but the system, it didn't correctly validate what the engineer wanted to do. And so the CLI command took down numerous critical S3 machines, and it led to cascading failures and thousands of customers affected. And some of those were Docker Hub and GitHub and GitLab and Bitbucket. And tons of the tools that we use every day went down. I mean, Slack and PagerDuty, those organizations were impacted. And most of us weren't even getting the correct alerts to know that something was wrong, because even AWS couldn't update their own status page. Their page was showing that services were operating normally because they couldn't get that update out. Or in 2019, Office 365 went down twice within the same week. The first outage was January 24th. There was another outage January 29th. Millions of users were affected. I mean, during that first outage, some of the customers were without service for over 12 hours. They couldn't send or receive emails. Some businesses were just like, okay, yep, we're done. We're closed for the day, because they couldn't access the tools that they needed. And just in case you thought you'd avoid this by not using Microsoft or AWS, well, Google had an outage in 2019 that also had cascading effects. This one was really interesting because it wasn't just businesses that were affected. This affected individual users. I mean, Nest thermostats even went down. Imagine having a cold house because Google Cloud is down. Apple was affected because they relied on Google Cloud, and the iCloud was affected. People couldn't access docs and other files. And I'm not sharing these stories for fun because we like to make fun of cloud providers. That's not the case. The reason that I'm talking about it is because failures are everywhere. You can pick a date and search for outage, and you're going to find something. Just today, there was a reported outage of Starlink. According to one of the Reddit users, the user terminal, which they refer to as Dishy, it performed an unexpected update in the middle of the day. I still haven't seen the updates as to what the cause is or if they've released anything official. But the point is, failures are inherent to complex systems. And this means that unless we test for them, downtime is going to happen. So think about going back to what Alina said about praising proactive homework. And when I talk about complex systems, one of the things that's happened in our industry is the shift from on-prem to the cloud. And it's great because we see decreased cost and low maintenance. There's no servers to rack. We have better ability to scale. We have on-demand infrastructure, but we do sacrifice control for that. I mean, overall, though, it's been great. It's led to a need to look at new ways to build apps. We can no longer have these giant monolithic apps when the cloud is designed for smaller compute resources, but having a lot of them on demand. And this means moving from monoliths to microservices. And that's great because moving to this service-oriented architecture, it increases developer velocity because teams are no longer bound to the speed of the slowest team in your organization. And it also means that there's a better ability to scale not only the applications, but our teams as well. The bad part about this is that you break down a monolith into services. You usually start with this large macro services and you have tons of services. And as you continue to break things down, it can lead to hundreds and then maybe even thousands of microservices. So when we look at these diagrams, they're the death balls from Amazon and Netflix. These are from actually circa 2015, and they're maps of their services. So can you even imagine what they might look like today? That bad part is that the larger, more distributed, it means there's more complexity. So we need to look at new ways to test and handle failure so that we can avoid people going on call, or no, can't avoid them going on call, excuse me, getting called at 3 o'clock in the morning. And downtime, it costs money, right? And there's quantifiable costs that we can look at with downtime. Talk to your accounting or sales teams. You can look at revenue. I think, what was it? There was a major outage with a major online retailer, I guess I should say, on a Father's Day that cost them 50 million some odd dollars over a couple hours. But other quantifiable costs are employee productivity, like how much does your time cost? And customer chargeback. So if you breach an SLA, if you've got to give those customers money back, if you breach that contract. And then there's those costs that are a little bit unquantifiable. So brand defamation, right? Customers don't want to use broken products and they will certainly tweet about it. I know I will. And sometimes you can't quantify this, but other times you can with stock prices. Like in 2017, there was a huge outage that British Airways had, and their stock lost $75 trillion overnight. So that is a cost that you can quantify. And employee attrition, though, people don't want to work at places that are always on fire. And so it's a vicious circle, because then people leave and then there's less people to handle the incidents, which leads to more burnout. So IHS estimates that 700 billion is lost annually to downtime. They estimate that Amazon retail loses huge amounts, like 220,000 per minute, and that the average company can lose 300,000 per hour. So if we want to do a little availability math, if there's 8,760 hours in a year at 3 nines of availability, that means you can be down for about 8.76 hours of downtime per year. And if the average company is 300,000 per hour, multiply that by 8.76 hours, and that leads to an annual loss of 2.63 million. So downtime costs us money. And so if failure is inherent and costs us a lot of money, what do we do? I did say trillion, Caleb. I should double check that number though. But I'm pretty sure it's accurate. Maybe it was billion. It had to have been billion. Anyway, failure is inherent, costs us lots of money. Chaos engineering can help. And it can help because we can identify weaknesses so that you can build more resilient systems and maybe avoid some of these incidents. It also trains you to identify incidents, and it trains those teams to respond to incidents. So those on-call teams can now have the opportunity to understand and learn how to respond to those. But before I talk anymore, I guess I should tell you who I am. As mentioned, I'm Julie Gunderson. I recently joined Gremlin actually from PagerDuty. So I was over at PagerDuty and I focused on helping organizations understand best practices when it comes to incident response and reducing downtime and putting engineers on call. So kind of everything that Alina just talked about. And so Gremlin was a natural fit for me. I also organize DevOps Days Boise, although I don't know when our next event will be. And for a little bit of fun, I live in Idaho and I make jewelry out of circuit boards. So here's my email and my Twitter handle. I love talking to people. Reach out to me if you have any questions or just want to chat. As mentioned, I work at Gremlin, and we're a company focused on helping you build more reliable and resilient software and processes. And to do this, we built a chaos engineering platform so you can safely inject that failure into your systems and learn from it. So if you want to try, there's a free URL here. And well, the URL is obviously free. You can sign up for free and give us a try. Let's talk a little bit about what chaos engineering is. I'm not going to give you a huge history lesson. Chaos engineering is not new. It's fundamental to humans. It's actually how we do things. We want to try risky things to see the outcome. So for example, when I was trying to figure out how to get stuff off my components off my circuit boards, I found that putting them in a toaster oven was great. And I wanted to know what would happen if I didn't take the capacitors off first. By the way, they explode. But when you look at that, chaos engineering is like that. I had an idea. idea, these might explode. Put them in there, they did explode. But moving on with that, in 2010, Jesse Robbins started manually wreaking havoc in data centers by pulling out power cords just to see what would happen. And then also in 2010, many enterprises began forming disaster recovery teams to try to figure out how they could respond to incidents faster. And the Netflix engineering tools team, they created Chaos Monkey to facilitate Netflix moving from on-prem to the cloud. In 2014, Bruce Wong, he coined the term chaos engineer while working at Netflix. And that idea of chaos engineering, it began to seep out. And then we started to see wider industry adopting chaos engineering, moving from that reactive state to that proactive state. And then Gremlin was founded by Colton Andrus and Matthew, who were some of the engineers from those early days who left their companies to make the practice of chaos engineering more safe and easy to practice. So chaos engineering is one of those things that's unfortunately named. We love Bruce, he's awesome. Chaos is a little bit of a misnomer. We're really simulating the chaos of the real world in a controlled environment by carefully applying failures with an explicit hypothesis. So we use chaos in the scientific method. It's very methodical, it's very scientific. We want to start with a hypothesis. I think this is going to happen. And then we experiment to validate that hypothesis. And we want to start with the smallest increment that will yield a signal so that we can move safely from small scale to large scale tests and move safely from development to staging to production. We want to clearly communicate because communication is important. Alina talked about this in the learning. We want to share our plans with everyone. What if there's an incident? You don't want to negatively affect other teams because chaos engineering is all about learning and sharing what you learn. It makes everyone better engineers. So you can share internally with your organization and absolutely should. You can also share externally. We actually have a chaos engineering Slack, which is chaosengineering.slack.com, where folks share what they're doing in their organizations. They're sharing about the chaos experiments that they're running and what they learn. But we want to make sure that we're clearly communicating those outcomes with our stakeholders and folks that are involved. And chaos engineering is a well-defined process that requires regular practice. It's about iteration, just like our software is. You create a hypothesis, you run an experiment, you create tasks to improve your software and your processes. This is very similar. And so then you update your hypothesis and you repeat, and then you increase your blast radius and you keep repeating. To sum it up, chaos engineering is thoughtful and planned. It reveals weaknesses in our systems, both technical and human. And we look at where is our tech broken or insufficient? Where does the user experience break? Is our monitoring and alerting setup? Can we auto scale? Are the retries working? Where are our human and systems? Where are those processes broken or ill-equipped? Is the alert rotation working? Do we have documentation and playbooks? Is the escalation process working? So when Dave gets an escalation for every one of those 3,000 folks that are put on call, is that working right? We want to practice chaos engineering so that we can validate all these things. And lots of folks are like, yeah, we want to. It's exactly what we need. But there's a lot of excuses. And we've heard them at Gremlin all before. I've heard them when I was at PagerDuty. One of the big excuses is, well, we don't have time. We don't have time to practice anything or to do something big like this. Because daily operations are a time suck because generally we're reactively firefighting. So everybody has the same amount of time. We all spend roughly 8 hours a day at work, and it's what you choose to prioritize. And so what's important is that your business is up and available. And really, what is more important than being able to identify ways in which you're vulnerable? And that's a great opportunity so that you can move from that reactive firefighting mode into proactively preventing incidents. There's also the excuse of, well, we don't need to break things because they break on their own. And yeah, they do. Things break on their own, but think about the timing, because when they break on their own, they break on their own timing, which is generally 3 o'clock in the morning when you're asleep. And so Rather than things breaking on their own time, what if you can go ahead and proactively work with them so that they break on your own time, say 3 o'clock in the afternoon when you've had a whole bunch of caffeine and the entire team is engaged. Another one of the excuses is, well, we don't know where to start. It's just too scary. You really can start simple. You can start with just looking at, are your systems resilient to CPU pressure, resilient to memory pressure? Does your service restart if the processor container is killed? And then you can build on it from there. You can really start by just saying, these are assumptions about how our systems work. So we're going to validate that in a safe environment with a small blast radius. And so really there's no more excuses. Now is the time to start. And Bruce Wong, one of the favorite quotes that I have from him is that he said, getting your systems ready for chaos engineering is like getting ready to go to the gym. You can go buy shorts, you can go buy shoes, but eventually you just have to go to the gym. You just have to do it. And so now is the best time because our systems, they become more complex over time. So you should start when things are as less complex as they can be. But how do you get started? I want to give you some tips on that. You want to start small. You want to be careful. Start on a single service or a host. Don't start on the whole application or a fleet. You really want to start in a controlled environment with a team that's ready, that's aware of what you're doing, and then you can expand that blast radius out. You also want to try to maybe adopt the practice in development so that engineers are architecting for failure. Get confident in testing and development, then move to staging. Start small in staging, then expand your blast radius. Finally, move to production. And you can just start small and increase. And this is really similar to how we all do development. Don't overthink it. You can work iteratively, like you do with code. Move up the environments, like with code. We all know how to do this. And you want to think that no two environments are the same. So you do want to test in production. Staging is not production, no matter how similar. So unless you're testing in production, there's no guarantee your recovery safeguards will function. So testing in production, it sounds scary, but that's where our customers live. And so we want to be where they are. And that's why you want to look at starting very small with that small blast radius. In addition to starting small and in development, your tests should progress as well. So you can start with things like resource failures, such as CPU and disk and memory failures. And this is what the cloud is built for, the ability to have these resources on demand. So the ability to test for things like auto-scaling. Does your auto-scaling work? From there, you can move up to service failure. What happens when you shut down a host or kill your app? Service failures are like process killers or host pod container shutdown, skewing the clock. Can your service restart itself without manual intervention? Is traffic automatically routed to the restarted service if it's moving to a different availability zone or region? You want to ensure that your stuff is resilient. And once you've determined that your own services are resilient, you can move up to dependencies. So start working on your network, black hole your dependencies, cut them off from the network, change your DNS, increase latency, increase packet loss. So you want to see what happens if a dependency is unavailable. What happens when the network is bad? Can your service handle things asynchronously? And once you have all the infrastructure issues in order, you can move up the stack into your applications. So what happens when you inject latency into your code? How does your application respond? Can you see that in your monitoring tools? What if you throw errors? Do you have the right logging to capture these errors? Are there the proper timeouts and retries? And then finally, you want to have confidence in your resilience enough to automate it. And game days are fun and they're awesome, but they're manual. So like anything we do in tech, automate it. If automating it, that it removes the potential for those human errors. And it also prevents you from regressing or drifting back into failure so that you're working towards that continuous chaos and automation. Because as I mentioned, game days are great, but eventually you run them enough, they become kind of boring. So automate what we can. You want to have confidence in your resilience to a particular failure mode. And then it's all great in theory, but when I talk about chaos engineering, a lot of people are like, does it actually work? So Backcountry is a great story here. They had a 72-hour SLO breach on Black Friday in 2017. They have this really cool fleet of robots, and it goes around the warehouse and it picks up orders. But during this incident, they actually had issues writing to the database that caused the shipping warehouse robot to misship orders during the time. And after that Black Friday, their engineering team, they had a fix, but they actually couldn't verify it because they couldn't really run the issue in staging since there were no robots and not an entire warehouse full of products just for a staging environment. So they installed Gremlin in production. They ran a game day. They verified the fix. They actually were also able to identify other latent bugs. And the result is that the pickers didn't misship orders despite the introduced latency. And Black Friday 2018, it went off without an incident. MailChimp also, they wanted to verify that what services were included in the critical path, and that critical path being the set of services which are required for that customer to have a good experience. So they black holed a service that they thought this wasn't in our critical path, but it caused a 503 page across the entire web app. So since that service was deemed to only be providing a nice to have information, it was removed from that critical call path. And the result was that that information was used to enhance the customer experience, not to dictate it. So one of the things that we look at here in that microservice architecture, it's important to limit the points of failure to only those that are necessary. And it doesn't really matter what your business is. You rely upon your customers. You want them to have that good experience. And so all of these folks listed that you probably recognize some of the names, they're proactively testing for these failures. The point is, with chaos engineering, you can really bring that science to your team and start practicing some of these so that it makes the experience for our customers and for our engineers and for our organizations better. And with that, you can check out Gremlin for free at this link. You can ping me on email or Twitter. And I just want to open it up for Q&A now with Alina and I.